Hello everyone, so today in this video we are going to solve a question of LeetCode, that is binary tree right side view. This is 199 question LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Given the root of a binary tree, imagine yourself standing on the right side of it. Written the values of the nodes you can see ordered from top to bottom, right? We need to order all the right side of the nodes, right, the right side nodes from the top to bottom, right? In this first example, if we see this binary tree, all the right elements are 1 3 and 4, and we are just ordering it from top to bottom, so we are returning 1 3 and 4 here, right? So let's quickly understand this example. So we have a root node 1, then we have two child, first is 2 and second child is 3, right? And this 2 is having a right child 5 and 3 is having a right child 4, right? This is the first example, and what we need to do is we need to return all the elements on the right side. So these are the rightmost element, so we are just returning these right elements, that is 1 3 and 4. This is our answer vector, right? Now let's see how can we approach this. If you know a BFS traversal, then it would be more easier for you, because in the BFS traversal we are just returning the last element of the each queue, right, in the each iteration. Let's say if we just traverse this binary tree level wise, right? If we do a level wise traversal, so the each element on the level, right, each element of the each last element, right, the last element of the each level is the answer, right? Like in this level the last element is 1, so this is 1, right? Similarly for this second level the last element is 3, so this is 3. Similarly for third level the last element is 4, so this is 4, right? So if you don't know BFS traversal, let's quickly understand this, right? How can we do a BFS traversal here? So what we usually do in BFS traversal, we first make a queue, right? So let's make a queue, and we initially push the root node into the queue, right? And when we have a root node into the queue, let's just check this root node. So for this root node, we will just, we are basically traversing this part, right? We are traversing this part, and for this root node, we will just push the left and right child here, right? So the left child is 2 and right child is 3, right? And we have just completed the iteration. We are just traversing through till this. So for this iteration, the last element is 1, right? So we will just push 1 into the answer vector, right? Now let's see for another one. So we are now checking this part which has popped out this, right? So for this, let's check the left and right elements. So for 2 we don't have any left one, and the right one is 5, so let's push 5 here. We are basically traversing this part, right? We are just traversing this part now. So for this 2, the left, nothing is there in the left side, the right is 5. Now for 3, there is nothing at the left side, 4 is at right, so let's push 4, and 3 is the rightmost element, or we can say the last element of this iteration, so we will just push 3 into the answer vector, right? Now let's see, and we just popped out both the values, and let's see for this part. So for this part, for 5 we don't have any child, and for 4 we don't have any child, so we don't push anything here, and the iteration is completed, and this is the 4 is the last element of this iteration, right? So we will just push 4 into this, and we got our answer vector, right? So this is our answer vector, and we have easily found out the rightmost element, right? So I hope the approach is clear to you. If you still have any doubt in this approach, feel free to comment it down. This is basically a classic BFS approach, right? And it makes it more easier to directly print the rightmost side, right? So let's quickly move to the coding part, right? So let's see. So let's first check if root is not null, right? If root is null, then we will be just returning a empty vector, right? We don't have anything, we will just return the empty vector. Now let's see the other condition. So before that, let's make a queue to store the elements, right? We were just storing the element in this queue, so let's make this queue. So queue of pre-node, let's name it queue only, and initially let's push the root, right? We just pushed this one initially, so let's push one into this. So queue dot push root. Right, now let's run a while loop until queue is not empty. Right, until queue is not empty, and for iterating whole level, right? For iterating each level. In this example, we iterated for this level, then for 2 and 3, and for then 5 and 4. So these are the levels, right? So let's see. This is the first level, this is the second level, and this is the third level. So how we can iterate this? So what we do, we just like initially we have only one in this, right? So we will just store the size of the queue, right? So let's store the size of the queue. So int n is equal to queue dot size, and let's run a for loop to iterate through this whole queue, right? So let's run a for loop for int I is equal to 1, I should be less than equal to n, and I plus plus, and in the each iteration let's pop out the front of the queue. So let's keep this into a tree node variable. So tree node, let's name it temp is equal to queue dot front, and let's just pop it out from here. So queue dot pop, right? And what we also need to do is, let's say if we want to return, or we can say add this rightmost side into the answer vector. So what we need to do is, we need to add the last element of each iteration, right? So the last element of each iteration is basically the element which is equal to the last index, right? So let's say we write a condition here, if I is equal to n, right? If this index ith value is equal to nth value, it means it is the last element. So in this condition, what we need to do is, we need to push this into an answer vector. So answer dot push back, let's push this value. So the value of this would be, let's just copy it here. Yeah, so the pushback and temporary, and the value of temporary, right? And let's make a answer vector here to store the values. So vector of integers, and let's name it answer. All right, this is fine. Now let's see, we just completed this iteration. No, this is fine. Now let's push, like if, let's push like we have just iterating this, and let's push these elements, the left and right child. So if temp left is not null, then we will just push it into our queue. So queue dot push temp right and temp left. Similarly do it for right. So if temp right is not null, so queue dot push temp right. Alright, so this is fine. Now at the end, just return answer from here. Alright, this is fine. Let's just run it. Yeah, it's working fine. So let's just submit this. Yeah, it's working fine. So let's calculate the time and space complexity of the solution, right? So the time complexity is big O of n, right? The time complexity is big O of n because we are traversing through all the n elements of this tree, right? And the space complexity, right? The space complexity is big O of h, right? The space complexity is big of h because at most we are just storing the h elements into this priority queue, in this queue. So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.